Today, we are going to discuss percent yield, which is part of the core subject, physical science. Our learning competency is calculate percent yield in a reaction. Percent yield is a ratio of actual yield to theoretical yield. Actual yield refers to the amount of product produced in the experiment. It is also called experimental yield. It refers to how much would you make in the experiment. Theoretical yield is the maximum amount of product produced through calculations. It has something to do with stoichiometry. It refers to what you should have made. Recall that stoichiometry is a section of chemistry that involves using relationships between reactants and/or products in a chemical reaction to determine desired quantitative data. In Greek, stoikon means element and metron means measure. So stoichiometry, literally translated, means the measure of elements. I will explain to you what is percent yield in a practical way. For example, you baked 20 cookies, but according to the recipe box, you should have baked 24 cookies. Now, if you compute percent yield on that, 20 cookies divide by 24 cookies times 100%, it is equivalent to 83.33%. Let's go now to our sample problem. When potassium chromate is added to a solution of 0.500 gram silver nitrate, 0.455 gram of solid silver chromate is formed. What is the percent yield?
Solution. Check if the given equation is balanced. Is this equation balanced? You are right. It is not balanced. We have already discussed balancing equations last time. As a review, let us solve this problem. You have to list all the elements on the reactant and product side. So you have here potassium, chromium, oxygen, silver, and nitrogen. Now, in this case, you notice that silver for both sides are not equal. So, we must place a coefficient of 2 here in silver nitrate, and silver will become 1 times 2, which is equal to 2 atoms. Nitrogen will become 1 times 2, which is equal to 2 atoms. Oxygen, 3 times 2 is 6, plus 4, we have 10 atoms. Notice again that our silver is now balanced, but oxygen now isn't equal for both sides. So, the next step is we write a coefficient of 2 here in KNO3 so that potassium will become 1 times 2 equals 2 atoms. Nitrogen will become 1 times 2, which is equal to 2 atoms. And oxygen will become 3 times 2, which is 6, plus 4, which is equal to 10 atoms. Check if all the elements are now equal for both in the reactant and product side. Potassium, check. Chromium, check. Oxygen, check. Silver, check. And nitrogen, check. So, our equation now is balanced. This is now our balanced equation. Based on the problem, there is 0.500 gram silver nitrate, which produced 0.455 gram of silver chromate. 0.455 gram is our actual yield, and silver nitrate here is our limiting reactant. We have already discussed how to identify limiting reactants last time. As a review, limiting reactant is a reactant that gets used up first during the reaction and determines how much of the products are made. Once we know the limiting reactant, we can now calculate the maximum amount of product possible, which is called the theoretical yield. Since silver nitrate is our limiting reactant, we can compute the theoretical yield based on this limiting reactant. So, solving for the theoretical yield, we will start with 0.500 grams silver nitrate times its molecular weight. We should write gram here on denominator so that it can be cancelled out with the given. So you have this. Gram silver nitrate is now cancelled out. We are left with 1 mole AgNO3. We will use 1 mole Ag2CrO4 is to 2 moles AgNO3, so that mole AgNO3 will be cancelled out. And to get the gram Ag2CrO4, we will multiply it by its molecular weight, which is 331.8 grams, cancel out with mole. You can get 0.488 gram Ag2CrO4. And this 0.488 gram Ag2CrO4 is what we call theoretical yield. Since we have already computed our theoretical yield and actual yield is given, we can now solve for percent yield. But before proceeding, let me just tell you why is it that there is difference in theoretical and actual yield. The difference between theoretical yield and the actual yield for any reactions may have one or more of a number of causes. Some of the reactants may remain unreacted when the reaction is complete. Some of the products may be lost when liquids or solids are transferred from one container to another. Contamination is also a factor. Human error often plays a role in the process of doing the experiment. Actual yield is based upon measurements, and there is no such thing as a perfect measuring device, just as there is no perfect scientist to take and record these measurements. Okay, so we can now solve for our percent yield. Percent yield is equal to actual yield divided by theoretical yield times 100%. 0.455 gram Ag2CrO4 divided by 0.488 gram Ag2CrO4 times 100%, cancelled out gram Ag2CrO4. We have the answer 93.2%, and that is our percent yield. Importance of percent yield. It gives you a feedback about how sharp your laboratory skills are. It forces us to consider why theoretical yield was not attained. Was it an error in calculations, in measurement, in poor laboratory technique, or are there other factors at work that need to be reconsidered?